Computers are really good at doing number crunching. They can do mathematical computations at speeds millions and even billions faster than a human can. So it is no surprise that most of what you will see in existing code is a form of arithmetic expression. Before covering the theoretical concepts of expressions, let us practice writing some expressions using Python. One of the ways to practice writing arithmetic expressions is to use your interactive Python shell as a calculator. So let us do that. And we'll start with the simplest operation, and that is addition. So let's say that you want to add two numbers in Python. So if you use what we call the addition operator, so if you say 3 plus 5, you get the result that you expect, which is 8. You can also add non-integers, so you can also add floating point numbers, and a floating point number is the one that has a decimal. So for example, if you say 5 plus 5 plus 2, you get 7.5. Python also understands subtraction. So if you want to subtract two numbers from each other, so if I say 10 minus 7.5, you should get 2.5. And also Python has a sense of negative numbers. So for example, 10 minus 12, you should get minus 2. If you want to multiply two numbers together, remember from an earlier video we said that to multiply numbers you use the star. So if you want to multiply 3 and 2, so it is 3 star 2. So this star in here, this is the multiplication operator in Python, and 3 multiplies 2, or 3 times 2 is 6. You can also divide numbers. So for example, if you divide 8 by 2, you get as a result 4.0. Now one thing you should note in here is that this division is a floating point division, so it expects floats, and the result of it is also a float. That's why you're getting 4.0, because you have a decimal in here. This means the result is a float and it's not an integer. And because of that, you can divide a small number by a bigger number and you should get a fraction. So for example, 3 divided by 4, and the result of this should be 0.75. Now there is another operator for doing integer division in Python. So for example, 4 divided by 2. So this division operator here is an integer division, and the result of this integer division is supposed to be a whole number, or a number that is rounded to an integer. So 4 divided by 2 is 2. Compare this, for example, with 4 divided by 2. So this is the floating point division. As you can see, as a result, it's 2.0. It's not 2. So the result of the integer division is an integer in here, and the result of the floating point number division is a float. So for example, let's say that you are dividing 1 by 2. So if you take 1 divided by 2 using the floating division, what you get is 0.5. But if you use the integer division, so 1 divided by 2 using integer division, the result is 0, because the result of an integer division is an integer. Another operator that you have in Python is the exponentiation operator. So let's say that you want to take 2 and raise it to the power of 3. So for example, 2 raised to the power of 3 is 8. And you can use also floating point numbers in here. So for example, 2 raised to the power of 3, so 2.2 raised to the power of 3 is 10.648000. One thing also you can do in Python is to find the remainder of a division. So let's say I want to find the remainder of dividing 8 by 5. So this percentage sign is finding or finds or gives you the remainder of a division. So 8, you know that the remainder of dividing 8 by 5 is supposed to be 3, because there is only one 5 in an 8 and you have 3 left. So far all the expressions that we have written only have one operator and two operands. So for example, in the last expression in here, we have the remainder operator and we have two operands. Your expression can have a sequence or any number of sequence of operators and operands. So for example, I can take 3 plus 1 times 2 times 2. So the result of this thing is supposed to be 5. So you can have a sequence of operators and operands. So what happened here is that the multiplication has been executed before the addition, because the multiplication has more power, or it has precedence over the addition. If you want to force an order of execution you can use parentheses. So for example, I could say 3 plus 1 times 2, and the result here should be 8, because I will add the numbers first and then I will multiply, and the result here should be 8. Now you don't need to have only literals in your expressions, so you could also have variables in an expression. For example, let's say that you create one variable, and let's call this variable distance, to store the distance traveled by some object. So let's say that the distance is equal to 1.5, and let's say the time it took that object to move between 2 points is 50, and maybe that's 50 seconds. So to calculate the average speed, so let's say we want to calculate the average speed of this object, so we know that the average speed is distance divided by time. Now if you want to see the result of speed, either you can say speed and that will show you the results, or you could also use it in a print statement. So for example, print the speed of the object is speed. Okay, and that's how you can use variables in an expression. Your math expression can also include a mix of variables as well as literals. So let's say for example we want to calculate the discriminant of a quadratic equation. So let's say that we have the elements of a quadratic equation: a equal 1, we have b equal 3, and we have c equal -4. We know that from math the definition of a discriminant is equal to p raised to the power of 2 minus 4 times a times c, and that's times a times c, and in this case the value of the discriminant is supposed to be 25. So that's how you can write simple expressions using Python. In the next video we will look at some of the theory behind Python mathematical expressions.